Now, next comes autocorrelation. So you know what is correlation? Correlation is used to find the similarity between the symbols. Okay. So correlation means whenever you transmit some symbols, you are always eager to find whether symbols are identical or not. For that, we are going to use the correlation and see here I'm generating signals. I'm generating signals. I'm sending this sequence 1 1 1 1 1 -1 -1 1 1 -1 1 -1 1. I'm sending this pilot sequence and I am finding the autocorrelation. Autocorrelation, at zero it will be big. So autocorrelation is an even function. At zero it will have maximum value, and either side it will be symmetrical. So you can find the symmetry. So this is the autocorrelation, which means that between symbols you have a lot of correlation. See, among the total number of symbols, I think how many symbols we have? 5, 10, 13 symbols. Out of 13 symbols, 1, 2, 3, 4. Only 4 are going to be -1. Remaining everything is going to be 1, right? That measures that it says that the correlation is very good. The correlation between symbols is very, very good. Okay, that is what is meant here. And now I'm again doing the same PAM. We are going to see what is the received signal and the pulse shape. This is the received signal and this is the cross correlation. See, autocorrelation is between symbols. What is cross correlation? You find cross correlation between signal and noise. So what is cross correlation means? Whenever two different signals are considered, you call it as cross correlation. Whenever a single signal is considered, you call it as autocorrelation. In the first example, you see, we found autocorrelation of pilot with itself. That is autocorrelation. When you do cross correlation, you will be finding the output signal. We'll be finding the cross correlation XC. See here, XC. So that is going to be the cross correlation signal. I am going to use cross correlation of the signal with the pilot. So received signal, when you do with pilot, that is going to be called as cross correlation. And this is the pulse shape of the pilot sequence. The pilot sequence is given here, right? 1 1 1 1 1 -1 -1 1 1 -1 1 -1 1. Whenever you have a one, you will be sending this raised cosine pulse. And whenever you have a -1, the pulse shape will be changing. Okay. So whenever you send a pilot signal, it is just to understand that whenever there is a presence of pilot signal, the receiver will understand that and it will decode the signal accordingly. Pilot is just like it will be used as a reference signal. So when you add pilot signal to your transmitter, when the receiver knows that you are going to add the pilot signal, it will use the pilot signal as a reference to demodulate your received signal. Okay, that is going to be the thing. And this is going to be the extension of that.